What do you consider a machinist?
Full-blown out machinist has it.
Yeah. Did you just have manual mills and lathes?
That's it.
There?
And there was 0 CNC whenever I started. 0.
Oh, and for those of you guys that don't know, this is my dad, Louis Aycock. I'm Nicholas Aycock, and he's the one that started a machine shop that we're about to go into here shortly. So thank you for watching. Subscribe. We'll have more to follow. One thing. So how did the, as far back as you can remember, how did the shop and everything begin? Or how'd you get into machining, I guess, is the first question.
I got into machining in high school.
Okay.
I was headed to welding.
Yeah.
And my dad was working at a place called Astro Space Laboratories, and he was a designer. And he said, man, you need to go into machining. You know, that's something that you'll never ever regret because you'll learn so much.
Yeah.
And I got over into welding, and I looked at how basic welding was at that time. And yeah, there's some great welders out there, but it's kind of a bottleneck.
Mm-hmm.
You know, once you learn it and you're great at it, then where do you go next?
Yeah.
And then I went into the machining area at the trade school.
What do you remember? What year you were in high school on that?
And that was 77.
77. Okay.
And that was a long time ago, man.
Yeah.
But I went and looked at welding class, and then I went and looked at the machine shop class. And Jimmy Woods was the teacher there at the time. And I had no idea that machining was what it was.
Yeah.
You know, I'd never been exposed to it whatsoever.
Mm-hmm.
So making screws and I didn't even picture in my lifetime that's how those were made.
Yeah.
Or how things were made until that point in my life. And then I walked in, I thought, oh, this is how all this is done.
Yeah.
You know, so there's an endless amount of knowledge when you look at a machinist handbook and all the techniques and methods that have been learned over the centuries.
Yeah. Did you just have manual mills and lathes?
That's it.
There?
And there was 0 CNC whenever I started. 0.
Mm.
You know.
Tape machines, they came later, right?
Yeah, not much after that. They were there, but not in that scope.
Okay.
They were just being developed and everything. So,
you
know, the upper echelons of machining and Bowens and people like that were doing all the developments with machining companies and things like
People
that.
had the money.
Yeah, and 99% of the shops in Huntsville didn't have nothing like that. Even the arsenal was all manual machines, so everything that went up in space and everything that got built and blown up, and it was all done manually.
Yeah.
You know, so all the development of it started off in the manual area, so that's all I ever knew.
Yeah. When you're in high school in Huntsville, were you was space development already coming up?
Oh God, yeah, man. That you're talking about the Apollo projects and all that in the '60s. You know, we landed on the moon during the '60s, so all of that was built and done there, and a lot of it in Huntsville.
Yeah.
You know, so all the old machinists that after I come out of high school, of course, all of them will tell you they forgot more than you ever know.
Yeah. Which they're probably not wrong.
No, they're not, you know. And probably
because they did all the complicated stuff just on manuals. They didn't do it on
man,
CNC.
there was no CNCs or tracer mills or tracer lathes.
Okay.
You know, those were in act. So you've got hydraulics and everything working together with lathes.
Yeah.
And you'd have a template on the back side of the lathe that you would follow.
Yeah.
And everything. And then, of course, your stylus on the back side would reflect the tool radius on your tool, so you would mimic everything that you done.
Yeah.
You know, a lot of things that had to be repeated were done with tracer mills and tracer lathes.
Didn't know that.
So all of those items were developed, and that was your CNCs back then, or you would have turret lathes. Or you would have like Harding's chuckers with logic in them built in, and you would program them with pins or pegs and cams, so different things would function at different times. You know, and you'd rotate cams around so your peak points would be at certain points when your other tools were coming in and all that. And we were building gyros, my first job, you know, holding plus minus 50 millions. Yeah, no doubt, man. So,
So how did you do that? Like the lapping stuff?
no, man, you turned it. You handmade all your tooling.
Yeah.
Carbide, 883 carbide. You know, tools, hand tools, 3/8 tools.
Yeah.
And you would hand grind them all. And you would hand lap them, and you would hand hone the radiuses on them. And you're holding plus or minus 50 millionths with these tools you create.
Yeah.
You know, and that's almost an art in itself.
Yeah.
You know, but I was young and dumb. I didn't know no different. And I learned from all these older guys. And, you know, they were done it like breathing. And me, I'm just listening and paying attention and doing what they do.
Yeah, so you didn't know that 50 millions was...
Oh, no, man. 50 minutes. Okay, we use air gauges and plug gauges, you know, and you register this on an air gauge. You got to be between this mark and this mark on the air gauge. You're good.
Oh,
you know, and then you check the temperature of the part because, you know, it changes 4 or 5 degrees, you know, then it'll shrink out of tolerance. Or it'll grow out of tolerance, depending on, and the shop was kept at 69 degrees to 68 degrees. So, but that didn't mean that your oils, the further the day went on, you know, the more you ran, the hotter your oil got, the hotter your part got. So you have to compensate for that heat. So you have to compensate by math and do the calculation. So it'll shrink this X number at this many temperatures. So you had to run it at this size to get it to this size.
Yeah, makes sense.
You know, so all your 50 minutes, oh yeah, man, it's butt pucker time. But I was young. I didn't know no different.
Yeah.
So running it, yeah, I jumped right in there with the rest of them and have at it.
Okay.
You know, and then you have a method for
Was this at Martin Brothers? Or?
No. This was at a place, DeVault Ultra Precision.
Okay.
And that is where a lot of the guys I went to school with in high school went to work.
Okay. And then Martin was later.
Oh, yeah. Martin Brothers was a little bit later, all the English.
Yeah.
You know, but then I went from there, went to college.
Okay.
To play baseball and, you know, and enjoy myself there. Because there wasn't a lot of studying.
Just,
you know, I did learn a lot, but I wasn't necessarily a college student.
Gotcha.
I was a baseball player at college.
Okay.
You know,
so yeah, we all know how that goes.
And, you know, and the parties interfered with all of my studying.
Yeah. Or the studying
instead
of the party.
Exactly. You know, so young and dumb and chasing skirts everywhere and just playing baseball and having a good time. It didn't last very long. So I came back to Huntsville. You know, I spent a year there and figured out, nah, that really isn't for me.
Yeah.
You know, and what I know and how I see things.
Yeah.
And I didn't want a desk job. I didn't want any of that, or even the study time.
Yeah.
I mean, it's just part of life. You got to experience things to understand what you really want and what you don't want.
Yeah.
And sometimes life deals you a hand that points you in the right direction. Like, dumbass, you should have studied if you wanted to stay.
Yeah.
And if I didn't want to stay, then, you know, I did what I did.
Yeah.
But that sucks. But at the same time, I wouldn't be where I'm at now if I had stayed.
That's true.
You never
That
know.
worked itself out.
You know, so then I went to work at Machine Craft.
Okay.
And started to work there, and we were building MX missile beams and space shuttle components, exterior tank shields, and all the gussets that go around the external tank, so when it splashes into the ocean, they'll collapse and not damage the tank. And just, of course, I had a year and about 2 months under my belt holding plus or minus 50 millionths, and then I go in this shop. You know, a lot of things are now plus or minus 30.
30,000?
Oh yeah.
God,
You know, and a lot of this crap they're running, you could run with a tape measure. You know?
That's a different feel.
You know, and it's a different environment. Everything, of course, was manual still, and they had 2 tape machines, and they were just knee mills with a tape reader on them.
Yeah.
So you had encoder motors on X and Y, not Z, and they were building the doors that go on the shuttle.
Yeah.
You know, so they could exit the shuttle and all that good stuff, and to the cargo bay and all that kind of the big round doors they were building them, because nobody else around there had anything like that. So I become part of the CNC part of it.
Yeah.
And still doing manual work and then working in the CNC or NC part of it. And worked there, I don't know, 3-4 months. And then got an opportunity to go work on oil rigs.
Oh, yeah. Okay. Yeah.
So I went from thinking work to back work.
Yeah.
You know, so, but it was a hell of an experience. We spent about 8 months, week on, week off.
On the oil rigs?
Yeah, it's a week on, week off. So we'd drive back and forth from Huntsville. We'd come back with a pocket full of money, party for a week.
Then go back and do it again?
And go back, scrounge up enough money to get gas money to go back.
Yeah.
And then you go down there and you spend a week on the rigs.
Is this like New Orleans or?
It's out of Venice, Louisiana, which is as far as you can drive in Louisiana.
Okay.
And then we'd cross the Mississippi River, and we was experimental, exploratory drilling, basically, in the Mississippi Sound area. I mean, we'd be 16, 17 miles out in the Gulf and only be 16 foot deep.
Oh, dang.
You know, and we'd be drilling, and every once in a while, 700, 800 feet deep, we'll drill through a log. You know, big chunks of wood be coming up.
Really?
Oh, yeah, man. And it's weird. That's old. I did have the piece of wood. You know, of course, during all my chaos as a youth, I lost it.
Dang.
But, yeah, all those kinds of things happened. And so I got killed 3 different times. You know?
I'm already.
Yeah.
About keyword.
Yeah, I'm still here, so it didn't happen.
Yeah.
But, you know, testing the stack on it, you know, high pressure testing it. So if we get a high pocket of gas or oil, the stack's what crushes all of the pipe and prevents it from blowing up. Well, they were testing it, and unfortunately, the manufacturer of the rig didn't put in the right pipe, and a section of it blew up while we were down there looking for leaks.
Oh, Lord.
Yeah, man. About blew one boy off the rig. Just about did. And man, Billy caught him by his britches. Pulled him back in, but it was blowing holes in the side of it's encased, kind of like a room on its own. And there's big chunks of pipe, you know, half-inch thick wall pipe, blew up and blew big holes. It's like a grenade when it blew up, man. Just chunks of it went everywhere. We were just lucky enough it didn't hit any of us.
Yeah.
There wasn't nothing we could have done. I mean, it's like getting hit by a grenade. Because we was at 8,000 PSI on a 6-inch diameter pipe. And it's supposed to be registered for 10. And it decided it'd give out.
Damn.
And, you know, just like, of course, I was a grunt.
Yeah.
Running around scraping rust, painting spots and all that. So I'm up over about a 100-foot spot, you know. And I had a 10 by 10 across a board in a V. And I'm up there painting with my safety chain on the airline, you know, and getting all this painted, and all of a sudden this board decided it didn't want to stay where I put it. Of course, I should have put some C-clamps where it was resting in the V. It just flipped, and I go, doing, 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 you know. Luckily, I had a safety belt on.
Yeah.
You know, so, yeah, a few other things. And then we was lifting casing pipe off of a barge with a crane, and I'd strapped up 3, just like we always strapped up. And the guy that was running the crane, he lifted it up, and the wind caught one end of it, swung it around, hit the side of the rig, and one of the chains come loose on these pipes. And these are 16 to 18-inch diameter pipes, 90 foot long, you know, so they're huge.
Yeah.
Maybe 30 foot long. 3 of them made 90. And I was standing almost under it at the time he lifted, and it hit because I was getting 2 more pipe ready to go up. And it hit, and here they come. So I had a choice to run under the rig, which is the direction they were falling, or run away from the rig, you know, in the ocean.
Oh, shit.
So I chose the ocean.
Oh, you jumped in the...
And once I chose the ocean, and where it landed is about where I was. And, you know, these barges, the top of them solid steel, and those dead burn pipes hit, and they put a hole in that 1/2-inch thick plate.
Oh my God.
Yeah, man, I scrambling.
That's some pretty thick plate to just puncture a hole in.
But anyway, and then I guess about a month after these events happened over a period of about 4 or 5 months, and we were going back down to work, and car broke down. So the main man there had some other guys he wanted to work there anyway. That was part of his old crew. So they fired us, and that was on a Thursday. And Thursday, we turned around and had the car fixed, of course. And then we come back to Huntsville, and Friday morning, by 9 o'clock, I was working at machine craft again. So as a machinist, you're going to work.
Yeah.
You'll never be without work unless you have a choice.
Yeah.
You have a choice. You can always work.
Yeah.
Because people need machinists just like they need air.
I know we've been trying to hire for it forever.
And that just told me I made the right choice in life about the career I chose.
Yeah.
Because especially in a city like Huntsville, if you're a machinist and you're out of work, it's your choice.
Yeah.
It's not because, everybody, unless you've been blacklisted, and everybody knows you are just a screw up from day one.
Yeah.
And if that's the case, you can go to another city and you're going to get work, because machinists are few and far and in between, and good ones are even rarer.
What do you consider a machinist? Like a full blown out machinist?
Full blown out machinist has his math, his trig, his geometry under his belt, understands machining and processing a component without anybody else telling them what that is.
Yeah.
Someone that can pick up a print and a piece of material and get you a component back in a reasonable amount of time that is correct, and you don't have to worry about it. And if there's something wrong with it, he's the first one to know it, not the inspector.
Yeah.
He knows what he's giving you, and he knows what he's doing.
Now, do you think you have to be a CNC or manual or both to be considered a machinist?
I think your CNC machinists are lacking a lot of knowledge, because they depend on the computer to do certain things for them instead of the maths, because if you put him on a manual, he can't produce, he won't be able to manually produce anything. But the way the CNC industry is headed, and it is a good thing, you can produce a part 10 times faster, more accurate, and you can depend on that machine. You're not dependent on the man.
Yeah.
There's points and times where manual machinists are wonderful, onesie-twosie part, repair parts. You break a punch and you just need to shorten another punch and all that good stuff. Yeah, manual machinist is that. But if you want to repeat multiple parts and you want to take even one part and get a complex configuration out of it with today's designs, then CNC is the only way to go.
Yeah.
So there's top quality in both.
Yeah.
Okay, definitely.
But if you're a well-rounded one, you would know both.
Yeah, you definitely would know both. But some people don't have the opportunities.
No, they don't.
Because especially today, the kids coming out of school, they're taught CNCs.
Yeah.
They're taught that's the way. And they never had really the opportunity in these trade schools to learn a lot of manual equipment, because everybody is going to the CNCs.
Yeah.
But if you ask them to go back there and put this hole in on this location, on
don't
the
know.
manual, it's like, where's the button that tells it to go there?
Yeah, because I've seen you on machines, you had no idea what they were, and you figured it out because of the background.
Yeah,
because you knew both.
Well, you got to remember, it's always a XYZ for mills.
Yeah.
Or a A in case you're using an indexer or whatever.
Yeah.
And on a lathe, it's a XZ thing.
And even if it's a custom machine, it's made for a reason.
Yep,
So, like,
it has a purpose, and it always has a X, Y, and a Z, or some form of access to manipulate the tool or the material.
Yeah.
So all of it has the same principles, no matter what the configuration, no matter what it is.
Yeah.
All you got to do is learn its language.
Yeah.
And once you learn its language, then manipulating is the easy part.
Yeah.
So you just take things at face value and don't try to over-evaluate what it is.
Yeah.
And look at it, study it, read the book if necessary.
Learn to adapt.
And adapt to what it does, because it had a purpose.
Yeah.
Just like a horizontal versus a vertical versus a multi-axis. And you're normally only doing one thing at a time.
Yeah.
You know, unless you're with like a screw machine or something like that where you can multitask multiple tools at one time.
Yeah.
Then you have to consider clearances and your tooling and all that good stuff, how it affects each one during the process. But normally it's one step at a time.
Yeah.
Anything beyond one step at a time, you're overthinking it anyway, unless you're processing the part ahead of time.
Yeah.
You know, you need to look at it and process the part so you don't work yourself in a corner, so you have a method to hold it, to put that hole that's over here that you can't reach.
Yeah.
When do you put that hole in?
Yeah.
At what point do you do it? When you have stock, so you can put a couple of dowels in so it rotates it up the right way so you can fixture it to get that hole in?
Yeah.
You know, or you in a 5-axis so you can rotate it and it's no problem.
Yeah.
You know, all these things come into play whenever you're looking at processing a part, what equipment you have available to be able to manufacture this part in the most expedient and time-saving method. And also you have to consider stresses in the material. What is the material? How is it structured? What grain direction is the material in? So when I start machining it, can I release this and cut that warp out of it? You know, after I rough it out, how much stock do I need to leave depending on the length of the part, the thickness of the part?
Yeah.
All of these things play a key role. Am I going to machine this down to a web that's small enough and thin enough that the warp is pretty negligible?
Yeah.
Or is it going to be a dominant factor in this part, so I need to leave enough stock so I can remachine this after I release it out of a vise, let it warp, put it back in and recut it so I can have a flat component to start with.
Yeah.
You know, how do I do that? And that's where processing a part is probably, I'd say, 95% of machining.
And it's the hardest thing to teach people because it takes experience.
It takes a lot of experience, and it takes understanding tooling. It takes understanding materials.
Yep.
And if you're going to heat treat, you know, that also has a huge factor in who's doing the heat treat. Are they going to hang this part when they heat treat? Are they going to lay this part down? Do they have a furnace big enough to hang this part?
Yeah.
You know, because it will sag. Because you're bringing this up to austenizing temperature. And austenizing temperature on some materials is very close to melting point.
Yeah.
And when you hit that, just like taking it and heating it with a settling tank, you try to use that to straighten parts. Well, guess what? They're heating it that hot too, and if they have humps or flanges or anything on this and they don't support it properly, it's going to warp like crazy because just gravity is going to cause it to warp in the heat treat process.
Yeah.
So all these things is a factor in processing, and there's a multitude of things that you have to observe in the configuration of the part. What is the part's finish tolerancing? Can you restrain the part and get what you need out of it? Because they don't have a flatness call out, but they have a parallelism call out.
Yeah.
Parallelism is not flatness. So can I bind this part down, get what I need out of it as far as parallelism, and let it do what it wants to do?
Yeah.
And normally that's not a good practice, because guess what? You have to make your lengths correct, your hole locations correct. And if you let it do what it wants to, and it warps or whatever, and you're going to have this part twisted, you're going to have this part bowed, and your hole locations can't be perfect, because in reality, if it bows in a dome and you have holes down here that go straight whenever they twist.
Yeah.
So you got to CMM that or check that. How you going to check that?
Yeah, that's a lot. So
You know,
all in
so-
the processing.
So processing, learning machining is wonderful.
Yeah.
Okay. Machining is great, but if you don't have the processing down, then machining is going to be a battle and a fight continuously.
Yeah.
Because if you can't process a part correctly, then the machining aspect of it is negligible, because you can machine anything.
Like when to
But
make a
can
fixture,
you get
when
it
not
from
to.
A to Z and get a part that's to print and understand the process from A to Z has some curves in it?
Yeah.
You know, and you got to understand when to, when not to, how to fixture this part, how to approach the part, how to approach the type of material that it is, being its tool steels, carbides. You know, and no, of course your carbides aren't going to warp or do anything, but you can't machine them with a dadgum carbide end mill either.
No.
So it's all the different aspects of machining that have to pile into the processing part of everything.
Yeah.
And that's where your planner and all those kind of guys that are doing the quoting and all that good stuff really need to be a process person.
Yeah.
Because if they can't process the part to get it to the quoting process correctly, then you'll never, ever nail the numbers that you need to make an accurate quote.
Yeah.
It's just impossible because they can look at that part, oh, that's going to take 10 hours. How do you figure that? It's the first question out of my mouth.
Yeah.
You know, how you planning on holding this? All right, what about your jigs and fixtures to get this to where it needs to be?
Yeah.
You know, and those are the things that only experience teaches you. Because you can have people tell you all day long, this is how I do it, this is how I do it, this is how I do it. But until you machine a component and understand that component's reaction to even a dull fly cutter, dull inserts introduces stress to the layer of the top of the material. And if you cut with a dull tool, and that's part of the machining, then you're introducing stresses that if you go through a stress relief process, it's going to cause your part to warp.
Yeah, like heat treating it and stuff like that. Yeah.
So you always understand that if you have too dull a tool, the depth of your stresses, because you're taking those molecules and you're pushing them instead of cutting, and it hits a resistance point that it starts to cut, okay, and separate. But you'll normally get a ragged, jagged, nasty looking finish, but you might have one little insert that's prominent that's still sharp. Finish looks good. Ain't nothing wrong with this. Okay, well, all the stresses may penetrate down into it 10, 15 thou, depends on how dull the one insert is.
Yeah.
And then you go, well, that finish looks great. You take it out of the vise and it goes boing. What happened? Well, a lot of cases it's dull tooling. You might not even realize it because the finish looks good. But what if you got one dull insert on this insert cutter